All right, everybody, we're going to talk about composition of functions and how to compose two functions. The composition notation sometimes looks like this, and when you read that, you read it backwards. This reads G composite F of X. So that's how you read that. And this can also be written like this, which reads F of G of X. So that's the real basics of how you read it. Let's talk about how you do it. When you want to compose two functions, you give yourself two functions, say an f of x. I'm just going to make up something here, x squared minus 4, and a g of x, let's say x plus 3. All right, and if I want to do f of g of x, here's what I do. I go, and let me change colors here to make it real obvious. I go and I take G, and what it is, I put right there. In other words, I'm going to take this part and I'm going to put it there. Okay? So watch as I do that. I'll do this in black again. So this will be f of, that part, this part here doesn't change yet, x plus 3. Do you see how this went there? Okay? Because that is what g of x is. Excuse me. So then, and let me show you in red again, the trick to doing it from here is that you go up to the original f, you put parentheses around every instance of x, and then you replace those parentheses with these ones. So instead of writing f, I'm going to write this, but right here, I'm going to write this in parentheses. So this is going to equal parentheses, x plus 3 squared. So this became this. Okay? And maybe I should show you that in red parentheses there. Those are the same parentheses as up here. Okay? And then that minus 4, this minus 4 right here, is added on to the end. Then you got to figure out an answer for this, and you got to simplify as much as you can. Okay, so this is going to take a little bit of side work. X plus 3 squared is x plus 3 times x plus 3, which is, and then you're going to take this and distribute it to each one of these. So that's x times x plus 3 plus 3 times x plus 3. And then you distribute this way with everything. So that's x times x, which is x squared, plus 3x, that's x times 3, plus 3x is 3 times x, plus 3 times 3 is 9. And so we get x squared plus 6x plus 9. So then that is that. So it's x squared plus 6x plus 9, and then minus 4. And then I can put those two together because they're just constants. They're just regular numbers. So I get x squared plus 6x plus 9 minus 4 is positive 5, and that is f of g of x. Okay. Let me recopy that onto a new board, onto a new page, and I got f of x equals, what is this, x squared minus 4, x squared minus 4, and g of x, what was g of x? It was x plus 3 equals x plus 3, and let's do g of f of x instead. So that'll be g of, and f of x equals that right there, so I'm going to put that into here. So it's g of x squared minus 4. And then again, I'm going to go to g, because of that g right there. I'm going to put parentheses around every x, and I'm going to replace these parentheses with these ones. Okay? So this is going to equal parentheses, and originally it was parentheses x. Now it's parentheses x squared minus 4. So that takes care of the parentheses part, there and there. And then we have that plus 3, this plus 3 over here on the end of it. And then we just need to simplify. Now this one's a lot easier to simplify because it's just x squared. Let's call it plus negative 4. Minus and plus negative are the same thing. Plus 3. And these parentheses here, they don't really mean anything. They don't do anything other than group it from where it was originally. So we get x squared plus negative 4 plus 3 is negative 1, and you might write that as plus negative is the same as minus. So we get that g of f of x equals x squared minus 1. One interesting thing to note is that when these equal constants, let's say f of x equals 5 and g of x equals negative 3, there's no x here, no x over here. So that means if I do f of g of x, I'm doing f of g of x, and g of x just equals negative 3, which means that I would go into here and put parentheses around every x, and then replace those parentheses with these ones, but there are no parentheses in here. So f of negative 3, that's like putting the negative 3 right there, and it still equals 5. And if I wanted to do g of f of x, then that's g of f of x, which is 5. So that's g of 5, but there are no x's to replace here. So g of 5, the 5 would go there, but no x to replace here. So g of 5 also equals negative 3. So then we get these answers. I hope that helps with composition of functions. Thank you very much.